Okay, let's get started. Alright, so, oh, I shouldn't be showing myself. Alright, what's going on here? This problem is surprisingly hard because, well, firstly, the problem is inverse digital sum. So let me, actually, I add PE status 684 doing. I finally decided to make some helper functions to help me manage this. Put it here, put it here, put it here. Okay, so yeah, so I don't know why this is the 5% problem. So to me this is actually quite hard because it's got multi-layers to it. So Sn is the smallest number that has digit sums of n. Okay, so S10. So imagine if you want to do like S100, you basically have to work out how many nines are contained in there. There's 11 nines. All right, so because 99 is 11 times 9, so your number has to be 11 nines. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then after that, there's still one left over, so you have to put one in front. So that's the smallest integer such that the digit sum is 100. You cannot find anything smaller than that. So that's like a huge number. So imagine if you're doing like S a million, you know, that's you end up with a huge number. Okay, not only that, so then SK, which is capital S, is the sum of S from 1 to K. You know, that's, so in Euler syntax this would be like this. So if K is large, this will be humongous. And then you're meant to, and not only that, they said why don't you do the sum of the S, the capital S, but for the first 89 Fibonacci numbers. I have a function here to compute the Fibonacci numbers, but it's like Fibonacci number 90. That's huge. That's this big. So that's a sum of a sum of a sum of a sum. It's going to be huge. It's really, you have to find really, or you have to do a lot of maths to simplify it. It's not that easy. Alright, anyway, okay. So how do I do this? Well, if you look at the Fibonacci numbers, actually it starts in 2, or it defines the zeroth Fibonacci number 0. So S Fi, so F2 is 2, right? So therefore F3 is 1 plus 2, which is 3. Okay, so and we're meant to do the F of that. And you see that I actually don't need to, this F here is just one more than the previous one, but of course the problem is the next one, F4, which is like 5. A bunch of things happen, and then F90, I think that's what they're looking for. That's right. So that's which is that. So that equals to the sum of. I'm just going to write out some algebra. Hopefully, I can figure something out. The sum of S, which is 1 to F3, something like that. And dot 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 all the way to F90. But of course, what you realize is that you can probably do some algebra to simplify this. So that's roughly what we're trying to compute here. That's going to be huge. I wonder if I can simplify this somewhat. So say for example F90, that's the same as F89 plus F88. Of course, that's F89 is F88 plus F87. Alright. Oh, actually, I just keep it as F89. I don't want to expand it. You can see here that, this part is all the same as that one. So if I compute F89, I just have to compute this, the rest of it, this part. So kind of that can somewhat simplify it. I'm still not very satisfied with this. I need to find a really good way to do this. How do I sum so many things together? It's just crazy. Obviously, even doing this many operations, even if they're additions, that would be crazy. Just too many. It's way too many. Okay, so I need to figure it out. So I need to figure out an easier way to do this. Why is this a 5% problem? It completely messes with my head. Okay, so see if I can do this. see if I can use this to do some live math. How do I start a new page? Ah, that's super annoying. It's not obvious how to start a new page. Okay, there we go. Create new whiteboard. So what am I looking at here? So ooh. I guess they kind of come in groups of 9. So I think it's like, oops. I think it's like S, that's a small s. We're looking, capital S of 2 plus, that's a capital 3 plus dot 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 plus S of F90. That's a huge number. Okay, but what does it actually equals? That's equals to S1 plus S2, and this is plus S1 plus S2. Okay, I'm starting to see a pattern here. S2 plus S3. Okay. Okay, so there's a lot of things that happen. Even with this huge number, so that's all capital. That's all small case down here. S1 plus dot 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 all the way to F90. Okay. I think so obviously that's 90 S1s. Oops, how do I go back? There's 90 S1s, 90 S2s, oh yeah, and then 89 S3s. But somehow that's still not going far enough, you know. That's not going far enough at all. We need to okay. I mean, it's just too many of them. There's just way too many of them. Wow, yeah, thanks open sources blog, but theoretically this is a difficulty rating of 5%. So yeah, it's meant to be an easy problem, but I definitely don't think it's an easy problem. But yeah, thanks for checking in, open sources blog. So I'm trying to finish all the easy problems first, before moving on to 10% and just build up, you know. Hopefully before I die I can finish every problem. Okay, so sounds like I need to do some mental gymnastics here. Of course that's just not good enough, because the last number here I'm computing a lot of S's that are just crazy amount of them. Okay, so okay, so but all of these just equals to mean, well, in total, I'm writing out the Fibonacci, the sum of the Fibonacci sequence of 2 to the 90th number. I'm writing out the total number I'm writing out is this much. Okay, and all of these numbers except the first 7 must end with a 9. Okay, so that's one thing I'll figure out. So I must have 9. So now I'm going up in, I'm going to go, okay, actually I don't have to go in the other order. Okay, so the no. Yeah. This is the last 5% problem. So I really want to finish this. Okay. The idea I'm doing now is, so I got 1, 2, that's the first two numbers. 1, 2, 3. Okay. 1, 2, 1, 2, 3. What's the fourth Fibonacci number? Okay. Okay, so from the 7th Fibonacci numbers, starting from the 7th number, I have 1, 2, 3, 4, 5, 6, 9. And then I'm going with 1, 9, 2, 9, 3, 9, 4, 9. That's the Fibonacci 7. So that would be the Fibonacci 7. So S, small s, F7 would be like this already. Okay, so okay. How do I move around? Okay. Okay. And then 1, 2, 9, 19, 29, all the way to Fibonacci of 8, 21. Whoa, actually, so that would be like all the way till 99, 199, 299, 399. So I'm just manually trying to draw out a few examples, see if I can figure out some pattern here. That would be S of F8. I guess it should be small s. Interesting. So yeah, I'm getting a lot of these bad boys here. Okay, open sources blog says S is simple to compute. Okay, small s is easy to compute. That's correct. That's very correct. And S needs to know the highest S and then mostly compute 9 something to compute the sum of the last digits. That is correct. So it's 9 times 1111 to compute the sum of his last digits. Okay. Yeah. So yeah. That's right. So I have, yeah, but yeah, the problem is FIP 90 is a big number. If you do capital, so what I'm saying is, if you look at the, if you do that FIP 90, right, that's a huge number. So each of the individual components are easy to compute, but in fact, because there's so many of them, if you compute each of them individually, it just take too long. So like small f90 by itself, that's easy to compute. F90 minus 1 is also easy to compute. Modulo this number, that's easy to compute. But just the sheer number of them, there's this many. So so if I just do the naive solution, which is compute this, sum them up, that will take too long. So I must be able to figure out a way to compute everything, work out how many there are. Oh, actually, come to think of it, if I focus on this level, if I can compute this one bad boy, then I only have 90 of them to compute. Yeah. Oh yeah, the modulo help break it down. Yeah. So modulo. So okay, maybe I should just focus on doing this thing, because I know exactly how many there are. S90. Yes. Okay. S90. Because that's just the sum of these bunch of things. Okay, so I might be onto something here. So, oops, sorry. Yeah, so okay, so maybe I should focus on computing the largest number, figure out if I have an algorithm to compute that. So SF90, okay, that will equal to S1 plus S2 plus dot. I know I'm using dot SF90. Okay. But this is not the best form to write it. And then the best form to write it is like this: 1, 2, dot 90, and then 19, dot 99. Okay. And then dot all the way till however many 9s it's supposed to be. I think it's modulo 1. Okay, so and that's the number of numbers here is F90. So I can probably find a way to sum all of these numbers, in one formula instead of doing. Okay, so maybe if I can compute this efficiently, then it's only repeating this 90 times, so that's not too bad. Okay, so I just need to, I think I'm onto something here, because so let's confirm that. I think I vaguely remember. So FIP90, FIP90, I really should FIP90. This is crazy. How can I get a number here? It's huge. It's a huge number, but do I not need to do big int? Let's make it easier. 684. Okay, so catch all of these. What's fib 90? Okay, and then modulo 9. Yeah, so 1. So modulo 9 is 1. So so I know exactly how many numbers there are. Okay. There's this many number. If there's this many number, oh, this is actually really interesting. Except for the first 8 numbers. Except for the first 8 numbers, all the numbers are 9s. Right? So except, so consider SF90, okay, which equals to S1 plus S2 plus all the way to SF90, right? Okay. Only the first 8 number have unit digit less than 9. Okay, that's it. All right. So, what's the sum of 1 to 8? Sum of 1 to 8 is 36. Okay, so it's like, so it's 36 plus all 9s, and I know exactly how many 9s there are because, you know, like well, the number of 9s is exactly this guy minus 8, right? So that's this many 9s. So that's this number times 9. That's my unit digit. So, but of course, fib 90 is quite a big number. So therefore, there's you know, there's this many digits. There's this many digits. Plus 1, you know. So if I loop over, you know, I have to, well, the loop will compute the units, the tens, the hundreds, the thousands. Oh no, it's like up to the thousands, only up to 3 into this loop. So that's way too long. So I should be able to sum up. I should be able to work out. And actually, I also know exactly how many 9s are there in the 10th digit. Okay, so it's exactly times 2 times 90, right? So that's, I'm just counting the 9 digits. Okay, so therefore, you know, all the way up to x equals to this. So all the way up to x, 8 times x. No. So get rid of the first 8 numbers. Okay, get rid of one more. Okay, so that's all the unit. That's all the unit digits gone. All the unit digits gone. And then get rid of one more. Okay, so yeah. So that's 8 unit digits, so 1 to 9. And then after that, 1 to 8 in the 10th digit. And then after that, it's all 9s. Okay, I see a pattern here. I see a pattern here. So, if I'm looking at the x, so that's the first digit, the second digit. So looking at the x digit, I need to do x minus 1, or 8 minus 1, that's how many I need to, and then times it by x minus 1, so that's how many previous digits I've gone through, and minus 8 times 9 times 10 to the power of x minus 1 digits. So okay, so that's 9 times 2 minus 1, or 10 to the power of course it's 9 to the 1 minus, okay, that sounds about right to me. And of course there's like the 1 plus, you know, the 1 in front, okay, so plus, you know, all the 1 to 8s, plus all the 1 to 8s, okay. One should probably use modulo as early as possible. Yeah, that's correct. So, but even if I'm doing so all I'm saying is, I don't want to, in a loop, I don't want to be computing this, and then computing this, and then computing this, because I need to go through x of them, and x is Fibonacci number divided by 9, because that's roughly number of digits in there, and x is still a huge number. Like x is still a huge number. X is a huge number here, so I don't want to be doing that. So I want to be, so Fibonacci is huge. X divided by 9, Fibonacci number 9 divided by 9 is still huge. So my loop will have to loop through so many things. So therefore, I think what I'm trying to say is I should try to find a formula that summarizes this into just a few computations, you know? And I think it's possible. Okay, so okay, that's one. Okay. I have a feeling that it's better to compute 9 numbers, you know. So yeah, get rid of that. Okay, so yeah, so that's always the Fibonacci number minus 9, minus 9, minus 9, minus 9. And this one is going up by a power of 10 each time. But this one is always decreasing by 9 each time. Big 9, 1 to 7. Okay, for example, the open source block says, for example, compute big 9 to the power of 100 divided by 1 through 7. Why 1 to 7? So big 9 to the power of 100. Okay, this, yeah. So if you follow my logic here, so say, so you know, if I say this guy up here, see if I can copy into this, you know. kind of can, but it looks really bad. How do I enlarge it? Nah, it's bad. Just bad looking. So, I mean, I can do the modulo as soon as I can. So that's sort of implicit, but I don't want my loop to be doing exactly this, because I'm looping through a lot. I'm looping through this many. So I want to summarize this even further. Okay, so say this is equal to, what's a good, so I have S, let's call it T. So that's T1 plus T2 plus T3 plus T all the way to TF90. Okay. I don't have TF90, I have TF90 diff 9. Okay. Okay, so I think I can solve this. I think I can solve this into a much more compact form. Let me see what's happening here. So in digits of 9, write number for TS. Yes. It's, oh wow, Kale Miller 96. Thanks for following. I think I know who you are. As you can see, trying to do a pretty tough for me anyway, project Euler problem. So okay. Yeah, okay, so okay, feel free to give me hints as you go along. So okay, yeah. Oh yeah, thanks, Kale Miller. Oh, thanks for loving my work. Yeah. Okay, so okay, I think I get it. So T1 is F90 minus 9. Okay, and then that's how many basically single digits there are, times 10 to the 1. So more generally, Ti is equal to 9 times I. Instead of calling it I, call it J, because people might get confused with the imaginary number I. So, and then 10 to the power of, oh yeah, I'm not going to let you distract me, but I think the whole point is that people should be able to give me hints if they want and participate in this. Genuinely, for me, these are really, really hard problems. So, okay, so Tj is of this form. Tj is of this form, and I have to sum all of them. Okay. If Tj is of this form, can I simplify it? Well, obviously, the 9 is always a common thing, so I can factor that out. Maybe put that in front first. Okay. And this one is going up by a power of j, so that's fine. That seems rather fine. Okay. Actually, if I break it up like this, right? This is already, you know. Okay. Okay. I think I see a way forward now. So I hope the algebra is not that difficult to follow. So anyway, let's break it up even further. Let's break it up into this, and then 9 times this. Okay, so well, this one definitely has a closed form, meaning if I look at the sum of tj, okay, for j 1 to for j 1 to f90, this one definitely has a closed form because that's just yeah, that's definitely has a closed form. Yeah, so f minus 9. So yeah, so what I decided was open sources blog was you know, you're a bit confused by my f90 minus 9, isn't it f80 minus 8? So before it was minus 8 because I'm counting the numbers 1 to 8. They can only appear once in the digit, but I decided to include the 9. So I'm counting 9 numbers at once. So then I can just write 9 here, and then inside it, because if I write 9 here, then you know, they become simpler. They just become, you know, that's minus 9, that's minus 2, 9. The last one is just minus x9, you know. So, but if I keep an 8 there, I have to keep, you know, 9 times x minus 1 minus 8, you know. So I wanted to simplify that, and you know, so later on I just have to deal with, you know, instead of dealing with sum 1 to 8, I just have to deal with sum 1 to 9. That's weird as fuck. I'm confused. Okay, so Kale Miller is confused by how S20 works. Okay, so I got S10. Okay, so Kale, so you have to be careful of the capital S and the lowercase s. So S10 is equal to 19, that's correct, but only true for lowercase 10, lowercase s. Lowercase s 10 is 19, that's true. But capital 10, that's different. That's lowercase s1 plus lowercase s2 all the way to s10. Yeah, so that's why. So pay attention to the capital. That's the thing you were missing just then. Okay, so this bad boy over here definitely has a closed form. In fact, I'm gonna just put that out there. Yeah. Okay. So the sum of t1 to t whatever of 10 to the power of j minus 1 has a closed form. Okay, so does this guy have a closed form? Okay, so that's so not worry about the constant at the front. This one, j times 10 to the j minus 1, that's also got a closed form. Okay, that's it. I think that's it. That's all I need. So I got a closed form for all of these, so I can compute this bad boy over here. Okay, so nah, you're not dumb, Kale. You're not dumb. Thanks for loving my work. Yeah, totally. Okay, now I'm getting somewhere. Okay, so I just need to derive the closed form for this. Then I can do this using the closed form instead of summing this many times, which is nuts. Which is pure nuts. That's just way too many. Actually, let me actually find out how to say this number, which is roughly Fibonacci number 90 divided by 9. How do you even say this number? That's 1,000. That's 1,000,000. 1,000,000,000. 1,000,000,000,000. 1,000,000,000,000. So this number, so I could run a loop that sums over about 320 quadrillion numbers, or I could write it out using this sum. Then I'm done with it. Okay, so okay, so what is this guy over here? So actually, so what is this guy? What is this guy? This guy is sum of that minus the sum of that. Okay, so okay. What's sum of 10 to the j minus 1 for j equals to 1 to some big number? Okay, so okay, so that would be I think it's 1 plus 10 plus 10 to the power of 2 plus, so let's call this g. Okay, let's say tj is equal to the two people that commented on the stream. So open source block j plus Euler j. Okay, so that's the two parts. So I'm going the sum of oj, you know, j in 1 to some big number x is equal to this guy plus dot plus. Okay. Yeah, name it after name all the variables after you guys. Okay. Okay, so that would be that plus all the way to I know I wish I remember the formula to these things, but I sometimes just forget, so I have to derive them. I believe I need to go all the way to x. No, I need to go all the way to x minus 1. Okay, cool. Okay, so therefore, let's call that big OJ, the sum, just by definition. Oh, is that someone's recognized you for your... Wow, I mean, I don't know, man. This is a tiny stream. It's like, it's only got like 2 people watching or something, and I'm only doing it for fun. So most people watching are just my friends. I'm just hoping that you guys would, put it in the background and go, yeah, it's in the background, whatever background noise. Go and do your own stuff. Occasionally check in, heckle me a little bit. That's, and then interact a little bit. So this is my way of having fun. Actually, I just cancel all my Netflix and stuff because it's like, whatever, man. I couldn't be bothered. Nothing. I don't want to watch anything on there. So I much prefer doing something like this. So I could do it alone, or I could just stream it. So decided to stream it because actually I lose nothing by streaming it. Actually, 0, nothing. So might as well stream it. Okay, so it's like that's it. So therefore, if I times everything by 10, so 10 times OJ would be exactly the same bad boy, but shifted by 1. So shifted by 10. So it's exactly these guys plus 1 more, which is 10 to the x. Okay. So therefore, 10 times OJ minus OJ is equal to 10 to the power of x minus 1. Of course, the left hand side is nothing but 9 times OJ. So therefore, OJ is nothing but 10 to the power of x minus 1 divided by 9. Whew. Shit. Kale Miller says, Julia is shit. Oh man, Kale used to hang around, used to run the Sydney competitive programming meetup with me. He absolutely hates Julia. It's very easy to wind him up. Just mention how great Julia is. He gets really upset. Open Sources blog, of course, is a big Julia advocate, I assume. I don't know. Yeah. Well, thanks, Kale Miller. Kale, saying I'm an amazing streamer. Pretty sure that's just whatever. Okay, so actually, I'm actually getting somewhere because I figure out what the sum of the OJs are. It's just this simple thing. I wish I had remembered this simple formula from whenever, from high school. Okay, so now if I define, this is the Kale Miller bit. So K of J is equal to the sum of small kj's, for J in 1 to x minus 1. It's actually x minus 1. I got this wrong. But okay, so which equals to, I'll get rid of the 9 times 9, 81 constant in front. I just focus on getting this bit right. So it's like, what is this? This is like 1. I think it's 1. 1 plus 2 times 10 plus 3 times 10 to the power of 2 plus a bunch of things. And I'll if you guys didn't already know this trick, this is actually a really good trick to know. So I think the pattern is I'll get all the way to x times 10 to the power of x minus 1. Hang around, bro. Yeah, Kale Miller, hang around equals run and meet up according to ZJ. So, well, I did say we run the Sydney competitive programming meetup together. Now I think of it, if I didn't have a kid on the way, I would want to start something in Melbourne, but it's just too much work. So I just end up streaming stuff. Okay, so Open Sources blog says, I am not coding anything real up to this point. Well, yeah, that's the beauty of Project Euler as well, You gotta think through the problem before you code, because obviously the naive solution doesn't work. And open source blogs would know, because we ended up in a stream together, and we ended up not solving that problem, which turns out to be a classic computer science problem. And then open source blog ends up solving it, and then and finding a much more elegant algorithm for it. But that's what I find with these coding challenges. You got to think through what's happening. Okay, so this one is a bit trickier to do. But actually, okay, so it's got the 1 in there. So, but actually, if you think about this, show you the magic here, which is differentiation of OJ dx. Not dx. I want to differentiate it. Okay, so I think a better notation for this would be y equals to 10. Okay, so differentiate this with respect to y. Y equals to 10. So that's where all these 10s come from. So differentiation of this with respect to y, which is differentiate with respect to the second variable, some magic will happen. I think what's going to happen is, you end up getting exactly this, -1. Well, that's why I claim anyway. Oh no, actually you get exactly this. You don't need the -1, because imagine if this was y, dy is 1, so that's 1. Yeah, so that's not exactly true. I need to do plus y to the power of y to the power of x. Kind of. Yeah, plus y to the power of x. I needed one more term at the end. So I need to do 10 to the x. So oj plus that differentiated with respect to y is exactly equal to my kj. Okay. Actually, so I just need oj plus 1. Yeah, so that should be an x. Ox plus 1 differentiated with respect to y. Okay, so all I need to do, but I already know the closed form for this, which is up here. Yes. So all I have to do is differentiate this guy, kjy kx y. So yeah, so x plus 1. So differentiate this with respect to dy. Okay, so all I have to do is look up how to differentiate this bad boy and evaluate it for y equals to 10. Okay. So I think I know how to differentiate this, but let's do it this way anyway. So Wolfram alpha. How do I differentiate this guy? So I go dy to the power of x plus 1 minus 1 divided by 9 dy see if it understands it. Maybe I need to make it a bit more. Fx equals to this, and the fx dy. Oh no, sorry, that's just stupid. How do I differentiate with respect to y? Differentiate fy. How do I differentiate something? Okay, maybe I switch around. Done it. Differentiate with respect to y, that's just x plus 1 y to the x. So equals to x plus 1 times y to the x. Okay. So I think I've done the both parts of it now. So yeah, so that's it. So x, so my number here, this guy here, that's just equal to this, and this, they just have a different thing out the front, and the 9s cancel out. That's a 10, and it's 9 times 9 times that. Okay. Oops, I actually do have to go now. Well, thanks for watching in. So I have to wake up the missus to and then go have dinner. Oh, this is gonna be a short stream. Sorry, this didn't quite get to finish this problem, but all right. Hope you guys have fun, and you know, take care, and hope to see you next time. See you. Bye. Oops, actually, what I better do is try to be a good citizen.